It is an honor and privilege to welcome our inaugural speaker, esteemed Professor P. Radha Krishna sir, to this program. Professor Krishna has been in the profession of research, development, and technology adoption for about 28 years. He is currently working as professor and head of department of computer science and engineering, National Institute of Technology, Warangal. His research interests include data mining, big data, machine learning, and data sets and workflow systems. Prior to joining NIT, Warangal, Krishna sir served as a principal research scientist at Infosys Labs, Infosys Limited, Hyderabad, where he was associated with research projects leading to futuristic intelligent systems and analytical solutions. Dr. Krishna also served as a faculty at Institute of Development and Research in Banking Technology, IDRBT, a research arm of Reserve Bank of India and an associate institute of University of Hyderabad. As a scientist at National Informatics Center, Government of India, Bhopal, and as adjunct faculty at NIT Warangal as well as IIIT Hyderabad. At IDRBT, he was advisor to many public and private sector banks in India for implementation of end-to-end enterprise-wide data warehouse and business intelligence solutions. Sir, he was also a member of IT Advisory Committee, Insurance Regulatory and Development Authority, that is IRDA, India. Alongside being a member of editorial review board of many international journals, he has been member of research advisory committees of several academic institutes. Krishna sir has double PhDs, first one from Osmania University and the second one from IIIT Hyderabad. He has to his credit 15 granted patents. He has co-authored 6 books and has over 100 publications. So it is really a great honor and privilege and a great opportunity to have Krishna sir as the inaugural speaker. Sir, may I now request you to do the procedure.
Good morning to all of you, and thanks for giving the opportunity to take the inaugural session, the inaugural topic. And I thanks to Tiranjan Mahabhatra, who is following up for the last 1 week for this session. Okay, so I thanks all the management of this coordination of this FDP program. So let me share my screen and then I switch off my video. Is my screen visible? Hello? Can anyone please confirm that my screen is visible? I am audible.
Yes, sir. You are audible.
Yes, sir. You are visible, and I can see your screen.
As well as the PPT is visible.
Yeah. Okay. Thank you. Yeah. Once again, good morning to all of you. The topic is like a concepts of data science. So I mostly focus on some of the aspects that we usually look at the data science. More the fundamentals of the data science I try to cover in this next 2 hours. So and actually this itself is an area which is not at all come like a new kind of a thing, but it is coming out of multiple scenarios. It is evolved this scenario. So we will look into the few of those aspects and see that one how this data science is a entirely something like a new paradigm is giving from the previous technologies like data mining, machine learning, pattern recognition, deep learning, and all the things. So all these advanced technologies are mainly providing for the problem solving techniques. Okay? So that's what we always say. The problem solving is more important. Look at it here. Sometimes the problems which are given to us may be having a solution, right? And the solution could be in a simpler way. The solution could be very simple. And sometimes the solution could be complex. On the other side, if the problem is simple, and we may be having a complex solution, right? So could be a problem, could be complex, but you can have a simple solution. So this is where we have to actually, whenever a data scientist is looking about it, he has to look at this kind of the aspects. Because now, if you look at the few decades back, people are talking about the data analyst. So they analyze the data, right? And then they will go for the looking at it, what kind of a relationships are existing across the data, and what could be my predictions, my forecasting kind of things, right? But now people have started from this data analyst, they're making a role of a data science role, right? That is today the people also talk about the data scientist rather than having a data analyst, right? So that means there's a paradigm shift is happening. There's a paradigm shift is happening from this data analyst to a data scientist, where not only you are understanding the data, because somebody is giving me data, that means you understand the data, right? And then analyze the data, and then you need to do some more steps. It's not like a straightforward, you are going from this, giving the data to the getting the patterns. So now this data scientist is playing a major role in these aspects. Of course, today people are also calling another role called datologist. I don't know how many of you have gone to this one. There's a call a datologist. Like we have a radiologist, right? Similarly, we can have a datologist. That means look at this data. That means we have an ample amount of the data. Look at about this data and see that how we can visualize this data. Because when you can see a radiologist, when he can go through the X-ray and then some other these diagnosis reports, and he will try to say these are the kind of symptoms, these are the kind of problems that they're having, right? Similarly, a role of data analyst also comes into play, saying that from this data, can I some find patterns and everything. But what is the benefit of getting these kind of patterns is mainly to solve the problem. So now we are giving a solution to the problem and trying to understand what could be the problem. And you can see, I have a very good example for this one. When we have I usually take this example of a star rocket launching. Suppose a rocket was launching, right? So this is star rocket. Star rocket means the vehicle will go take multiple rockets and launching in the space, right? So each rocket will have its own space, its own trajectory. So when it is moving, is it possible to find the trajectory of a rocket, of all rockets? So the problem seems to be more complex, right? Then people have tried with many algorithms, and finally they land up with a simple linear regression can be useful for them to do it. That means it's simply like we are saying that y is equal to mx plus c. Or of course they can say it's like in the terminology you can say a beta 0 plus beta 1 x, right? And if you have so many quarters, you can say beta 1 x1 plus beta 2 x2 plus beta 2 x3. Here you can see because the number of points that can be captured are very close, then even a simple linear fit also will holds good to get a trajectory. But of course, you need to get this entire trajectory information within a few nanoseconds kind of a thing. It's not like you can use a very high-end systems to get say that it will take a few minutes. They're not useful, right? So we need to see not only developing the solution, also it should be usability. Whether it is useful for us at the given right time or not. That is more important. So another problem you can see that there is suppose given a document like invoice kind of a document, okay, and this invoice document you are having the extracting the data, okay, and then they populating into the database. Now you can see invoice here. Invoice can have an invoice number, invoice date, and then the kind of a address, and then you have a table of items, and each table of item can have a description, item code, and then item amount, quantity, everything will be there, and then some totals will be there. And these forms could be like a straightforward. It could be the forms could be the native PDF documents, or it could be scanned documents. Right? If it is scanned documents, we can use OCR technologies, optical character recognition technologies, and maybe somebody who is familiar with the OCR tools like a Tesseract. Okay, and then you can see there will be some other tools that you can use like a Docker kind of a thing, and then extract the data, identify the elements, and then load into the data. But in the other side, suppose if you have a native PDF document, you can have a PDF box, and then that also gives you the geometrical coordinates of each text, and you can do it. But the thing is here, in a company, you have a number of layouts for a given invoice document, and also the nomenclature will be something different. Okay? So if you look at these things, it is very difficult to populate the items. Even if you talk about an address, the address will be 4 lines here, and in another one maybe address may be 2 lines. Okay? And even these line items are there. Each line item maybe span multiple columns. Sometimes the description of the line item is larger, it will span multiple things. So in my previous organization, I tried these technologies to extract the data from the invoice and logging it. It almost like took more than 2.5 years of time, but still we are not yet finished out to say how best that we can say automate this entire process. Because the layouts are in thousands of the layouts they are coming, because they have a type with the company having type with the many vendors. Only we could able to achieve only up to the 73% of the things only we could able to achieve, but still there are a lot of other invoices which you cannot able to do it. So that's why before going to solving the problem, it is always important whether we can go for whether the problem could be simple, and then how the solution could looks like it. If the problem is complex, how the look is. So the thing is, we should start from the identifying the simple techniques to solve it, and then move to the complex techniques, if not solved by the simple techniques. So that's why all these possible combinations one has to try it out. And then it comes to this machine intelligence. So one side we are looking at the data, and the other side you can look at this machine intelligence techniques. So when the computers are started, their main job is to automate the workflows, automate the business processes. Right? So whatever the business process that we are having, a railway reservation system or maybe supermarket kind of things. So automating the business processes. And at the other extreme, now today we are there, the AI-based systems where we want to take the decision-making process. So we want to incorporate this decision-making process as part of the workflows. Right? So that means the system, suppose if you ask a query, you have a chatbot, and you ask a query, and then you are getting response from the agent, the chatbot. This bot is responding to you. That means it is taking some kind of an intelligent aspects of it and then making it. So then that means we are moving from this extreme side, the one is like a fully automation, towards to the AI-based systems. And this actually developed the evolving this the technologies. So initially they started with the AI, that artificial intelligence, where we go for the more on the logic-based formalisms. Right? We use the predicate logic and the proportional logic, the initial programming language like a Prolog and Lisp kind of things they're using. We can find the frames, right? AI things. Then people have moved to the machine learning and pattern recognition. The machine learning, usually people call it as advanced AI, because today's terminology was completely changed what AI that we were looking at the few decades back. So now this machine learning came into picture. Of course, more on the more are working on this, images. The people also call like a pattern recognition. So they actually look at it, the different kind of algorithms, the sophisticated algorithms, and come to picture. People are looking at the statistical learning aspects for analyzing the data. Now people have moved to the more on the machine learning based techniques. Then people have started working about these technologies that can be used on the business scenarios. So when you look at people working on the business scenarios, then they are very fond of this one, having coined this word like data mining. So that means their direct relationship with respect to their businesses. So how the businesses can get benefit out of this AI and ML techniques. Then people are working on these agents, robotics. Like in the good example is like a chatbots. Right? Today a chatbot is also like a soft robot. This is a bot means a soft robot. So that means there will be like agent will be there. The agent, there maybe could be like a conversational agent who sits back end of this one and then try to interact with the system. Right? And there is another area which is coming up recently in the industry. Most of you may be aware of it. This robotic process automation. You can look at it. Earlier I mentioned it. There's automation is going fastest. This is actually was there, but now AI-based systems are coming up. Now they want to integrate these two things. Suppose there are tasks which are actually repeatedly happening. The task, right? These processes. Can I automate that processes? And using this soft robots, or maybe it could be hard robots. We know robots with robotics. We already know the robots. But you can see the soft robots, that means the agents which can do this process. You see, this is the automation which is happening more and more with respect to the soft bots. Right? So that's why people are spending most of the amount on today on this robotic process automations. On the other side, people are also spending a good amount of time on this chatbot. Even you can see the Apple, Microsoft, like Amazon, many of the advanced research communities, they're working on this. Like Apple has brought Siri, all of you maybe have heard it, right? And Google is having the Google systems, right? And Microsoft recently acquired semantic machines. So they say Microsoft semantic machines. So all these are trying to develop the conversational agents which can work for, these are like a virtual assistants, right? Virtual assistants. The virtual assistants could be an enterprise level or could be the cross enterprise also. Then there's a lot of work is happening on the autonomous systems. That means they want to move even the Google started the car, right? The driverless cars. And a lot of metros also having there's no railway coach or railway driver. So people are moved to the autonomous systems. And if you look at these lot of networking applications, also they want to go for today on the autonomous based, right? Even autonomous systems and self-immutable systems kind of things. Then the trend is going into the deep learning. I think all of you are familiar with this, the words, that the catching words today, deep learning. Even many of the students wants to do project, almost like a 95% of the students wants to do projects in the deep learning area. Right? They want to go for this, a lot of the deep learning techniques like RNNs, LSTM, CNN, all the things they're working on. So there is huge research is going on all these things. And now they say encoder, decoder things, and then transformers. So most of the work is happening nowadays in the deep learning. So, but here the idea is, as the technology is increasing, the people are trying to look at it more simplified of these things. The technology is improving, but from user's point of view, it is more thing. In the deep learning here, when you do the AI or machine learning or data mining, all these areas when you're implementing, one of the important aspects is like a feature engineering. So what features I need to choose to employ my data mining algorithms or my machine learning algorithms. But now when it comes to deep learning, it's almost like, this is also called a representation learning, which we'll see later if time permits. So here, we are not actually, the systems itself, the algorithm itself will try to analyze which are the prominent features in the given image or given the text or given data, and then work on that. Of course, as we progress here, you can see the models that are interpretable here, at least some of the models are interpretable here, but as we go more and more complex, the systems are not more the black box nature, because it's very difficult to interpret these models. Usually as a data scientist or data analyst, usually our role is to tell some kind of a reasoning out of the analysis what we carried out. So then people have started working on this data science. Of course, you may be surprising. Sometimes they say the people have started with the data engineering when people working with the data warehousing and data mining technologies. They say the data engineering aspects. So now they moved from engineering to the science. That's why now they are saying, is this AI for science or science for AI? Right? There are two the things are happening. Whether AI is for science or science is for AI kind of things. Of course, here when they comes to the data science, they are doing, as I mentioned earlier, they want to add something more. That more is in the form of a direct benefit to the businesses. Okay. So, of course, though we have all these kind of a sophisticated techniques, at the end, we are actually concentrated more, we have to give a lot of importance to this data, because data is generating large. And when data is going in the big data scale, some of you may be aware of it, the big data scale, we have a volume, velocity, and variety, and there are so many other characteristics are there for this big data, right? With the advances of this big data, the people are actually giving a lot of importance to this data science. Suppose if you can visualize a simple scatter plot you can draw, and you can visualize the graph if it's like 2 dimensions. If it's 3 dimensions is okay, if 4 dimensions, n dimensions, if the data is more and more, you can have how to visualize it. Right? That's why I just mentioned like a datalogist can. So the visualization of the big data is very difficult. The processing is also having a difficult. So to address all this kind of a characteristics, even the variety, that means a structured data and it could be the unstructured data, right? We need to look about the data that is available from the stores information about the sales information, and at the same time, they also should know the kind of a complaints that are coming from the users, which are more on the unstructured format, and these are the structured format, right? So people are working on this to handle this kind of a big data scenarios. People are looking at more on this data science also build up at the same time. Now the thing is, here this element, this data, which is prominent, right? That means we are living in the data-driven world. So if we are living in the data-driven world, the data sense is more important rather than which algorithm we are applying. Of course, you require the technologies to do that. But at the end, after employing all the things, can I sense the data or not? That means, can I get a meaningful information out of the data or not? Can I get the meaningful representations out of the data or not? So in the data-driven world, one has to give a lot of importance to the data science, data set, not data sensing of the data. That means the way that people are looking at it, that is the cognitive knowledge, having this one, can we incorporate this cognitive knowledge into the systems? That means the humans which are having this cognitive reasoning, they want to incorporate as part of these machines. So always there's a lot of work is going on as much as knowledge to incorporate this cognitive knowledge to incorporate into the machines, so that they can act as similar to as human beings. Of course, in the AI, when we come to the AI, people will call like a strong AI and weak AI. So can the AI can replace a human being or not? That's a big question. Of course, rather than going into the details, but we can say, yes, we want to try to incorporate as much as cognitive knowledge that people are having to incorporate into the machines. And today, you can look at it as the kind of activity which is going in the data science is not only left to the computer science kind of technologies, but it is expanding to all other fields also. It's like becoming like a multidisciplinary field. And I have attended one of the conference, and there's a good research paper was they presented. They say, suppose if I please a robot, suppose you have a robot was there, and this robot, usually if you give it some kind of a task, you say, okay, give me water. So it will go and take that water and give you the water to you, right? But suppose if you please this robot, can the decision, this could be changes? Is this the changes or not? So that means, suppose if we say, suppose sometimes we ask our mother saying that, "Yeah, give me a coffee," right? You can say, "Mom, can you please give me a cup of coffee, please?" Then you are pleasing, correct? Suppose if you please, the response will be also be entirely different, right? So can you expect the similar kind of a response from a robot by having this kind of things? That means you can see the fear, the psychology, right? So many other disciplines also coming into this data science area. So I'm trying to giving this the data science itself is not a picture which is coming up a newly, but it is like a happening most of the directions from the starting from the AI to the today's technologies world. Thing is, the thing when we talk about data science, one of the things we have to give a lot of importance and time to spend on the data, because data is an asset. Earlier, data is only like a processing element. Earlier days we say you can just take the data, process it, and store the data. So these are the things that we are looking for. Now people are saying, okay, I have a large data, but is this large data is useful for my businesses? Right? So now, can we have this data elements? Can we see more this one? Today, many of the times, even suppose if we forget our smartphone, if we forget our smartphone at home and go to office, we may feel that okay, something like a handicapped situation, because we see that something we are missing. Though we know that when there may not be any emergency calls, but still we feel that okay, we are uncomfortable in the situation. Say that I forgot my cell phone. It's not the cell phone that the instrument, but it's the data that is included into that. Right? But if you want to call of your friend, because the numbers are in the, suppose if you are doing a lot of payments using smartphone, then also you may feel that okay, a lot of information that is stored in your phone. Right? If somebody today lost a smartphone, they may not feel that the cost of the smartphone, but the data that was lost on this one. And you can see there's a few years back, there's a heavy floods in the Bombay, and then the one of the bank having the server in the cellar, they're having. So that's a big building. In the cellar they're having, but they never expected that such a huge rains. But due to that rains of that a few years back, the server is in the water, right? And even people cannot reach to that. Of course, they have a disaster recovery centers and everything already planned. So to take this disaster recovery plans, it takes some time. Right? It takes some time to be there. But suppose at that point of time, suppose you are a customer of that bank and you go to the bank branch, you go to any branch and ask that one, okay, you want to withdraw some money. And the bank manager says that your money is floating. Right? So that means this is very important, saying that on the information that you are storing, and then how much that you are using that information, keeping ready for the users when they require, or improve the business comparatively with other competitors. That's why people are looking the data is an asset. Earlier we have like if you take a house, you can say that's an asset. If you have a car, it could be an asset. These are the assets. Gold, if you have gold, you can say this is an asset. But now people are looking at it. So how much data that you are having, that it could be an asset. Of course, mostly looking for the enterprise perspective, not looking individual perspective, but enterprise perspective. The data, if you mine the data, you can get a very good information out of it, and that information can be really useful to improve your business. So this data science itself is like a multidisciplinary area. You can look at it. Earlier, people have started with the statistical learning aspects. In the statistical learning aspects, there are a lot of probabilities and statistics people used to use and try to do the predictions, or maybe analyzing the inferencing the data. And people are using the pattern recognition, machine learning, AI, data mining, databases, because storage is also another aspect of it. Because if you want to do the large data to store it, it is not an easy task to retrieve the information. And even there's one of the good research paper was there on how to estimate the size of the data. See, one can easily say that, okay, based on your data, I can able to easily assess the size of the data. But if you look at this in big data scenario, where data is crossing these gigabytes, petabytes, right? It is crossing all these kind of things, even petabytes, all this. So large, huge information you're getting. And every day, people are storing gigabytes of data. So now if you have the size of the data, and the data is actually going on storing in multiple distributed nodes at multiple distributed places, and if you want to find the size of the data, and if you go and count this one, by the time you go to this one, there will be large more data will be added here. That means you should have some kind of a probabilities, or maybe some other techniques you required to estimate the size of the data. So you have a good number of processing techniques or indexing techniques to do this on databases, data processing techniques. And again, understanding this data and also understanding the patterns out of it, we need a good visualization techniques. Okay? So all these techniques are contributing today towards this data science. That's why data science is a multidisciplinary. And you can see the cycle starting from this. You have a business strategy, right? And you had a domain knowledge, communicate it, present it, and then problem solving and then answers. Most of the times we spend time on this problem solving because we say that, okay, given a problem, can I solve it? But this could be like one of the element of your whole life cycle. If you look at this data science life cycle, you can see you have the businesses and business. This should be actually improve your business analysis, and you should change that analysis to be change the business strategies, and your new strategies will come up, and then new knowledge will come up, and then again process these things and they come. So that's why data science is a multidisciplinary field of study, mainly with the purpose of to address the challenges that are given in the big data scenario. So now what we look at this data science is we need a though it is multidisciplinary, we should able to try to make something that we have to come due to the businesses, right? So then how I can understand the customers? Suppose can I get some kind of a metrics to analyze my data, right? Is it be very good to say that one will be given the patterns that is understandable to the normal user? Because they are non-technical, right? So we can use a lot of statistical packages or a machine learning packages and develop a lot of models to do the things. So this way we have to come to this one. This how it is data science is different from the previous technologies like a data mining, machine learning, pattern recognition, all the things. The main thing is it's trying to give you a value added content. That means this it could be like analyzing the data and extracting the information from large databases. So even our definition of data mining itself is it is a process of extracting hidden information from large databases. That's the definition that we already have. Similar to machine learning, also we have how intelligence can be incorporated into the machines. So this is common to the most of the things. But what changes, what data science brings to the table is we need, in addition to the extracting and analyzing the information, it also should provide the value added content of that we have a business value. That means, can you tell that when my sales can be improved 20% by the next quarter, what to be done, how to do it? So this should happen, right? Suppose you can see today Toyota released a car, and can they know based on some kind of a user's feedback Can you show how long this model can continue? Do I have any problems with this kind of a design of this new car? Or they can be handled within the stipulated time, or they need, or I need to go for a launching a new car. Right? So these are the actually gives this. If you can, if the answers are provided to these, that means you are providing a lot of business value to them. So that means not only you are looking at the extracting, getting the knowledge out of it, but somewhere you need to provide the lot of value added content. So in industries, people are not interested. Suppose, of course, they will ask given a problem, and they are looking for a solution, maybe in kind of a prototype. But the thing is, what are the technology that you are using? Irrespective of that, whether they look at it, whether this client can happy getting these things, can get benefit out of this or not. So that's why they always look at it. They give a lot of importance. Even my manager, when I'm in my previous company, they used to ask, you see, this output of your thing is not as important, because you can say your model will give you like 80%, 87% accuracy. But can you say what is the outcome of that? Whether it's really giving a business value to our clients or not. So because they may not be worried about this 87% or maybe 90% or maybe it could be 50%. But at the end, whatever the model, that the system that you develop it, whether it can provide a business value to this or not. So that's why the important thing is, anytime when you take any kind of a project or any kind of a problem that you take over, you have to see that whether by solving this problem, you can have any value-added content you are providing to the end user or not. Okay? So that's why we always look at the usability of my solution. Okay? Usability of the solution. So that actually relates gives a lot of shift happening from the. So earlier the focus is more on the data operations, where I spend time on more on how my data can be stored and processed, and then once it is, then how I can access the data. Now they are moving. This is mostly a paradigm shift from data operations to the data science. Data science here, can I understand how they can I understand the data, and then can I analyze the data, and can I forecast the data, right? So that's why the operations, the simple data operations, are moved to the data science aspects of it. Today you can see any industry, either it could be like a healthcare, or manufacturing, retail industry, right? Automobile industry. So all these aspects, they're looking for this kind of a data science applications. So as you develop new models, and organizations also need process of deploying the analytics from research into the production environment, because they want to deploy this, whatever the solution that you are developing, directly deploy into their environment, production environment. So that means these changes which are happening, like once we are having good understanding of the data, and you can also have some kind of predictions of the data. Of course, earlier also, but from the statistics point of view, we have these predictions. So we only predict it, what will happen, but what to be done is not known. Suppose if you can say that I want to book an appointment tomorrow at some hospital, but do we really look at you can say that whether appointment available or not available, but you may not be seen that on whether what is the weather at that point of time, whether it is a rain or not. If it is rain, can you go because of you already have some symptoms? Though the appointment is possible, but can you really go based on your weather conditions or not? Right? If you say, of course, after all considering all the factors, that after the internal external factors, if you say that booking the appointment, that means it actually yields that yes, the purpose will be solved. So it's not only the predictions or analyzing the data, but you have to give the scenario in a holistic way to take some kind of a decision making process. So coming to from out technical aspects of it, when how this data science is happening, or what areas that it will cover, the data science, you can see this first is like a maths and applied mathematics. This is a very important that basically we should have a lot of aspects of this one. And today you can see the data science course. Of course, some of you are very interested. Maybe you can also recommend to your students. There is NPTEL having a course on data science. Even courses are also having a very good number of things in the data science. And this linear algebra, optimization, all the things are part of that. So simply suppose if you suppose earlier we used the matrix operations, right? And today you can see most of these deep learning techniques are using this matrix operations. Okay? And advanced techniques like many of these models, they will talk about eigenvalues and eigenvectors. I don't know how many of you have gone through these things. They say the eigenvalues, eigenvectors give a lot of importance to in the models. Because the purpose of this, because we already know what could be the eigenvalue or how to interpret it, right? So you can say eigenvector, which is having a major variance of the data, right? Eigenvector, and eigenvalue is associated with the eigenvector. Yes. So that means if you have a large data, right, and then develop some kind of a covariance matrix, and come out define what is the eigenvalues and eigenvectors, and order them in the order of eigenvalues, order the eigenvector and the eigenvalues, then you are getting the components which are actually representation of this one. That means you are compressing this data into this form. A lot of techniques like a PCA and all the things are principal components are useful for this purpose. And techniques that are using related to optimization, right? Like integer problem solving and all the things, integer programming and everything, right? So they are very useful. Even simple gradient descent methods. Many of the algorithms we use gradient descent methods. That is useful. Then applied statistics and data analysis one, where we focus more on this statistical modeling and statistical learning techniques. Even starting from this simple linear regression, multiple linear regression, logistic regression, all the things. The programming aspects also will be increasing for the data science purpose. And today, if you look at any of the courses outside, or maybe if you want to, somebody can say that you are learning data science, immediately they will ask which programming language you are working. Are you working Python or R? Right? So it's mostly tied to this data science. They're tying with the programming languages, more towards the programming languages kind of things. But of course, the understanding architectures are more important. The Python and R will be more on implementation side. And so this Spark environment is giving this Spark ML. And you may be seeing this technology, how it is improving. Even this, the people are coming with the new kind of a data storage structures, like even this called RDD, this is distributed databases. So Spark ML will be useful to give this, the machine learning aspects of it. See that the data which is coming in a different formats that we need to handle. Maybe later we'll see, suppose the data is coming from IoT, Internet of Things, because we have a lot of data from sensors, right? And the sensor data is continuously coming to the central servers. How you can store these streams of the data, right? So you have in the Spark and maybe in some other platforms, you have how you can store the stream data, how you can analyze the stream data to get an effective IoT applications. Of course, most of the advanced techniques like data mining, machine learning, big data analytics, and discovery, everything is part of that one. And in the data science, the area which is also be important is the data storage and management. Because when you're storing this large data, that what are the good index structure that you will use to retrieve the data? What are the organizations that you are keeping here, and how they are handling this distributed databases? Suppose if you have a computation, therefore you are given a query, and this query needs to be go to the multiple places. So how it will happen? Whether the relevant data is pulled to the central place, or the computation is moved to the data stored place, that nodes usually we call. People are coming with a good new paradigms like a map and reduce techniques. So how the technology is transforming towards the data science? So from statistics, our importance mostly will be given the estimations, right? So it will answer like the process that produced this sample. Suppose if it is a normal distribution, we say, okay, they use these formulas to estimate it. Right? If it is other distribution like a Poisson or binomial distribution, then you can see how this estimation will happen. In the machine learning, it's looking like a more somehow the thing how I can address the new samples that may arrive in the future, right? So this machine learning is giving most of the focus on building the model. Suppose in the face recognition application, you look at it, can I suppose if you say new face comes, can it will recognize or not? Today you can see all these smartphones or maybe the new cameras, they automatically having the autofocus, not autofocus, the auto focus in the faces, right? Suppose it try to identify even the new faces also and try to recognize where the faces were there. So those are the kind of things machine learning will do it. That means try to answer the questions for the future samples. So in the data mining, in addition to this machine learning things, it will also try to develop the interesting patterns, like a frequent item sets. So which other items can we go together, right? So that I can do my cross-sell or upsell in my businesses. So from these things, the data science is now giving us to say that how we can extract value to the data. See, you can use whatever mechanisms that you already learned, you can use it, but you can try to say that how we can extract the value out of the data. Suppose if you have like a Flipkart, Amazon, or kind of a eBay kind of a e-marketplaces, you can see they have a lot of recommendation systems, right? And today you open a YouTube and you are moving a picture, you are viewing a picture, then immediately in between that you will get some kind of advertisements, right? Suppose you have so many advertisements for there, which one to be placed to you, correct? Suppose if every time the same kind of advertisement, you may not be interested. But suppose if you want to look at this, the views of views to be and the advertising to be increased, you should know this. You have to recommend the advertisements that are more appropriate, that are looking for currently at that point of time for you. Otherwise, you just only skip and go ahead, correct? Even if you go to Flipkart and order the things and it will try to give recommendations, that should be more close to what you are looking for. So that's why a lot of improvements that you can suggest the improvements, estimates, impact, all the things will be part of the data science. So resulting to a added business value to the organizations or to the enterprises. So now, once we know that the data is an important element for us and it will give the added value to the businesses, we should see also when you want to apply these techniques, then we see what kind of a source of the data is available with us. And most of the data which we work on traditionally we are working on the application generated data. You take any enterprise is a computerized the operations, because you have the finance is finance, right? Finance data, or maybe the HR data, or maybe customer relationship management. So there are so many aspects of the things which are automated, and we have a lot of application generated data. So that means the application will generate the data, and those data mostly in the relational form, because people are using the relational databases like Oracle, DB2 kind of DB2 kind of things. So most of the data will get in a structured data, and there could be some kind of a policy documents, right? Customer complaints. So many like the government orders. So all the things will be also play a role in analyzing it. So it could be like having lot of unstructured data also, and more really prominently like emails, because today lot of people exchanging the emails. And sometimes the presentation is also more important, because when you go for suppose you want to buy a car and you go to a showroom, right? And you are looking for suppose you are looking for a Benz car, right? And the kind of giving a presentation, and then suppose you go to some kind of a normal car, right? And the presentation given to the customer, it should be entirely should be different, correct? The different kind of a presentation that you are making it. Similarly, when the different kinds of clients are approaching you, then how the presentation will make it. So this is all this data which is pertaining to the application generated data. But today we have social data, correct? Social media, where we use our Twitter, Facebook, WhatsApp, all the things, correct? So this using these social media tools, so the lot of data is generated by the users, and this data is not similar to this data, because here the structured form is very good. In unstructured also, the policy documents, everything will have a good meaningfully written statements or data, right? But here these users will write on their own. And sometimes user will go to see a website like a Flipkart. You go with different items, you will click and then check it, right? So that's a form as a click stream data. That means based on the data, the clicks, based on the clicks, I can know what is that your interest. I can analyze the user's interest based on the clicks that you are making on a website. Maybe you are interested mostly on the electronic products, and particularly looking at a high camera features, right? And the web logs, the logs which are given to web servers also can constitute the user generated data. And all these chart bots which are using texting, video, images, Twitter, Facebook, everything is data. Or even the reviews on the these sites also contribute this one. News articles. So all are like user reviews. Now news articles actually go into the like more structured form of it, but here you are getting the, because even we do not know this how the sentences are formed by the users. And then nowadays we are having a new kind of a data, which is a machine generated data. This is more interesting. You can see earlier, of course, and applications can generate the data and users are generating the data is okay, but now machines are self-generating data. And I have seen a few, maybe two and a half years back, I've seen they dismantled 2 robots because they are speaking in a different, they are interacting with a language that it cannot be understood by the human beings. Because of course, these people, humans only developed these 2 robots, and when they are communicated, sometimes they gone to the data which they are not able to understand. These humans are not, so they dismantle these robots. I don't know, many of you may have seen that news article. So that means machines also generate the data. More particularly that the events which are generating. Suppose you are in the traffic, and then the traffic camera can see that one, okay, you are generating, you are going very high speed, and that they send an alert to the control room saying that one, okay, this car is going very high. or maybe a traffic camera can say there's a large, huge traffic density happening here. Now it can take some action on that. So that means the events also will playing a major role. That events which are generated by the system. Right? Suppose a particular node is accessing this one, they are trying to access the data, but the data is not happening in the stipulated time. Then maybe it has to give some kind of message to the another node saying that okay, can you take over from here? And with the IoT, Internet of Things, this will be the data is increasing more on machine generated data. You can see all these things like even your car also generate lot of data, right? Your smartphone generating the data, right? It could be like a GPS or anything, measurements. So that the event data, scientific data, spatial data, and machine data, so this RFID, scenarios, all the things are contributing to the data. So we need to have a good understanding about the data source from where the data is generated. So the kind of a algorithm that you can use on this very clear data may not be useful here. Maybe you have to fine tune or maybe come out with your new models. Similarly, if you want to handle, you can require a more number of models. So that's why one has to give a good kind of a understanding, a good idea about the what kind of a data source that I am working for solving a problem. So that's why you need to see how the data is generating and then how the data is with us to do some kind of analytics. That means we need to have a good understanding of this data for learning purpose. So the data could be the structured data or unstructured data. So structured data is very common to use, but unstructured data like a video, image, or even the speech, maybe the audio, the music, or even the body languages. People, suppose you can see sometimes you want to analyze the election news, and then the content members will have the speech with a lot of emotions, right? So facial expressions, body language, gestures, so all these contribute to the unstructured data. Then you have to go by one more step, saying that what is type of the data? Either the data is a numerical data is given to me, or it could be like a categorical data. Then there are so many other bifurcation of this data, because usually you can see data could be like a binary, nominal, ordinal, kind of discrete like this. This is because when you want to apply an algorithm, the algorithm maybe works only on a few kind of data. Suppose if you have a neural networks, people are using the deep learning and everything, neural networks. So the traditional neural networks actually works on a numerical data. Suppose if you are having a categorical data, then you need to be able to transform this into numerical and then apply this one. Suppose if you are working in associational mining algorithms like a priori kind of things, the data should be in the binary format. Right? Data is in the binary. Suppose if you are having only sequence of items that you purchased, right? Then you need to have to binarize the data. So that means there's a lot of things, unless you know that one, okay, your algorithm works on the binary data and your given data is in the sequences, then you have to need to a transformation from here to here. So knowledge on this type of data is also an important aspect of it when going for a developing solution. Then the kind of data, because the nature of the data is also more important. Not only the type of the data, the nature also. Whether are you looking for a time series data? That means is the temporal content involved in the data is also more important to you, to the business or not? Right? If it is that, then we need to go for a time series kind of things. The sequence data, similar like in IoT cases, like a stream data, maybe lot of applications like a lot of applications maybe go for a GIS based applications look at the spatial data, right? Because today we have a lot of location aware analysis. So there you may be giving a lot of importance to the spatial data. So we have to understand the kind of data also along with the type of the data. And then while understanding the data, we should see whether given data is a normally distributed normal distributed data, or maybe some different distributions. Because many of the algorithms assumes that the data is in the data follows normal distribution or Gaussian distribution. So if your data is not in this Gaussian distribution format, and if you apply those algorithms, then the results may not be more impactful or meaningful to you. So this also will have a playing role on this on what kind of a distribution of the data was there. Of course, some people will go for the populations and sampling records because they cannot work on the whole data set. Sometimes you require for inferential statistics, you can look at work on the particular sample data. And there is also another way of that people are looking at the data as the data, whether the data is balanced or not. Okay, this is not from exactly from the kind of a understanding the nature of the data, but this is required to see how the models can be applied. Usually, particularly from the training the system, we classify the data. When we give this training data to the system, and the samples of one particular class maybe majority of the data considered to the one class, and the small amount of the data will be considered to the second class. Then what will happen? Suppose if you have a healthcare patient data, in that one you have suppose 95% people are data is normal data, and only suppose if you have a 5% is only the cancer patient data. Right? So the models should know that yes, you have a large data is from the 95, but your predictions are more focused on this one. Right? You want to predict the data whether they are going for a cancer or not. So that's why data is a balanced or unbalanced is also an important aspect. And how frequent that we are getting the data to model and then process the data. And sometimes this is also interesting aspect which I have seen. I face it when I go for moving from the academics to industry. Then I have seen though the organizations feel that they have a lot of data, but many of the cases they may not have the data, that unavailability of the data. Suppose somebody will ask you that, can you model, can you predict the tsunamis? Can you predict the tsunamis? You can say, yes, I have. You can give me the data. I can do the predictions. I can have a good number of algorithms. I can do it. Okay. Then you say, okay. Now can you give how many samples that you can give? Suppose you can say that how many you require. Then you can say, suppose if at least you give the 100 tsunamis data. Okay. Maybe a few generations are required to generate such kind of a data. At the same time, we cannot say that we cannot predict it. So with the available data itself only, we need to look at it and get the information. Maybe we need to look at the elements and the internal relationships, how it can be drive, right? How it will drive towards to this one. So finally, having understanding about the data, then we need to see what kind of a technique that we can use. We should have, because we have seen there are so many techniques are available. Okay? So you can use which technique to be applied. Today you look at this, suppose a Python, and then the Python you have like a Scikit and Keras, all these libraries are available. So all those libraries have a lot of algorithms. Suppose if you want to say that decision tree works good, and then suppose you want to test with the other ways, you can easily move it. Okay? So we don't require to even write code because we can use simply libraries. But unless you don't know why if I use decision tree, what kind of inference I can get, and what is actually how it works and everything. Right? So you should know which are the techniques that you need to apply for the given problem and given data. And once you get that, you have to also prove that it should be interestingness, because you have to say the patterns that we are getting here, the patterns which are getting here, it should be meaningful and it should be interesting to the end user. Okay. So sometimes a kind of if we form a kind of a taxonomy, this is also useful to give some kind of a direction. So how to apply an algorithm, a technique to the given data for a given problem. So now let us see this understanding the data to some extent. Any questions here? Hello? Am I audible?
Yes, sir. Yes,
Yeah,
sir.
yeah. Any questions are
Yes,
yeah,
sir.
because whenever we are in the full screen mode, we cannot see the participants. So that's why I asked any questions are there, so we can take where they can continue. We'll continue.
Participants, you can go ahead with your queries. If you have some queries, you can go ahead. You can ask now. Please unmute yourself and ask.
Okay, then maybe we can reserve the questions in the end because they are not coming. So let me continue.
Yes, sir. Yes, sir.
So now look at this data. See, that's how we started this data science problems. This is the data I took from the one of the book, the statistical learning book. It's a good book that is. So the data is pertaining to the, suppose people are doing the advertisement. If you give advertisement in the TV, how your sales were affected, or how sales are. If you advertise in the radio, how the sales will happen, and then if you advertise in the newspaper, how the sales are going. So if I just look at this independently, if you advertise in the TV, so you can have a sales. You can see here the linear regression could be a good fit, right, based on the data. Of course, you can see if you spend some amount here up to like this one, it's like you're having a very good predictions because the root mean the RMS values are very less, right? But if you go to this one here, this could be the very high. Though it's like a linear fit is more appropriate for the whole data, but if you look at this whole spectrum, you can see there is variations are there. But of course, yeah, if you look at the overall, is a linear fit could be really good. But in the case of radio, there's not a linear relationship. Though we can fit linear relationship, it may not be more appropriate. You can see there's not even happening much things in the one. The spread is more, right? And similarly, if you look at the newspaper, it's like totally out of, so the linear fit itself is not appropriate at all. Here, at least you can see at least there should be something was there for linear fit, but here that is also not. So by having a simple scatter plots, one can able to look at this one. Suppose if you combine, suppose if you look at this initially, suppose usually we call this is like a predictor value. This is the predictors, correct? Then this is the response variable. And if you have a predictors P1, P2, P3, okay, and then you can see the sales could be the response variable, how the sales can be done. So that means you can say this is sales. You can have a prediction of the sales. Usually the prediction will be usually estimation could be like a caps, right? It could be if it is linearly you have there. I can say beta 0 plus beta 1 of TV, right? I can say beta 0 plus beta 1 for this one. I say radio for this one. Suppose if you consider all three variables, then I can say beta 1 into TV plus beta 2 into radio, and then plus beta 3 into newspaper. Right? So it's like a function of all these things will be there for to get this response variable. And when you're doing this one, we also see how the least square fit will happen, right? Because that's what we are trying. Otherwise, there are many possibilities for there. I can fit this data. There are many straight lines I can use it, but I will only come up with the which is having a less root mean square least square errors, right? So I will use that line. I can take as a good plot for that. Here, the linear relationship was not there. Even it could be a non-linear relationship, right? The data could be non-linear. So with respect, like suppose somebody has having a number of years of education, and then how he can get the salary or income from this one. And here the simple visualization techniques, because mostly in the data science we look at the visualization techniques. These are like a box plot techniques, right? So this can also give you information about how the mean and variance you can have with respect to each and every. So you can, by looking at this kind of a visual graphs or visualization techniques, one can understand the relationship between the attributes that usually call like independent attributes and the relation with the dependent attributes. So then we look at these actually the types of the attributes. So so we usually look at this kind of attributes. They could be like a nominal. Nominal means when we suppose we are having like a roll numbers, right? In the students we have roll numbers, like a ID numbers, eye color, zip codes. But here we cannot say that one okay is the roll number 2 is greater than 1. No, it's only some kind of symbolic representation. Nothing else. It's nominal data. We cannot say 2 always study more than 1. Right? There's not like such a kind of a no ordering or no kind of relationship. It's just only representing individual elements. Even zip codes also like that. The other is like ordinal numbers where some kind of a ranking is involved. Some kind of ranking is involved. That means you are saying that when we give the students the grades, we'll say there's a grade A, B, C, D, E, and we always know A is more than value than B, B is more value than C, like this. That means there's some kind of a ordering is also involved. That could be like usually like a ranking kind of things. That's data is like ordinal data. And some data is like interval data where they have a more on like a dates, temperatures, some kind of ranges. They call like interval data. And also we have like a ratio data where you can use like X by Y kind of things. Right? So now you look at this, there are the properties of attribute values, and look at it. These attributes also depend some certain properties. So there are 4 properties, one like a distinctness, order, addition, multiplication. That means you can apply only the equal or not equal in the case of distinctness. Less than or greater than the comparison, like in order, if it's order, and if it's addition, and multiplication is the multiplication or division. Now you can see these kind of types of the attributes have different scenarios here. Like if a nominal attribute, you can only have this one, equal or not equal. You can say when a roll number is equal to another roll number or not. You can say whether equal or not, they are equal or not. Right? We can have only that. But in the case of ordinal value, you have now a distinctness and both order you can use. In the interval kind of attributes, you can have all these 3, distinctness, order, or addition. Of course, in the ratio attributes, you can have all these 4 possible operations. Because it is always good when you can say, suppose I go for a neural network and with some data where there's a weight will be multiplied by with some kind of a thing, the node value, got the node value. Unless it's like if you do not know what is this kind of a node is giving, suppose if you have some other data and you are multiplying with this distinctness, like a nominal attribute is there, and if you keep the nominal attribute as one of the feature, and doing this may not be useful. So that's why whenever we go for any kind of a algorithm, we have to see what its type of the attribute and what operations are possible and what my algorithm does on that. So these are some more information about what kind of operation that you can do, like a mode and entropy, chi-square test, all the things possible on like a nominal data, right? Some of the possible on ordinal and interval and ratio attributes. Sometimes we'll try to develop this the test like a p test, t test, z test kind of things, right? Or maybe we use for the harmonic mean. Suppose if you want to analyze the classification techniques, we go for F measure, where it is the harmonic mean of precision and recall. Then we say we should always see that whether how it is applicable to the scenarios. So mostly these attributes, when you're talking about these kind of attributes with respect to numerical data, right? So now we have a data, both can be structured as a discrete data and a continuous attributes. In the discrete case, we always will have a finite set of the data, finite values. That means it is like a well-defined, so you can say low, medium, high, low, medium, high. Like that, we have a defined. Of course, it could be a finite values or countable infinite set of values. So it could be infinite also, but again, it is a finite one because we know how many are there. But in the continuous data, in the numerical data, we have a continuous, like you can say a salary, it could be like a 0 to 1 lakh, it could be anything between this. So it's like infinite values, right? So the most of the data, even if we initially, though we don't go for this kind of numerical, like a nominal, ordinal kind of thing, first we'll see whether the given data is a discrete data or a continuous data. So now you can see a lot of applications how this with respect to type of the data and then the application of the data. So when we have a different kind of the data could be in the relational format or could be unrelational, non-relational. That means it could be unstructured data. Sometimes the data is also the semi-structured data because all now XML, JSON, all these formats are storing the data in the. Even our HTML pages are also in the semi-structured data. That is a semi-structured. It is like more structured, unstructured, and semi-structured. Right? The data could be in the graphical data, sensor data, streaming data. Different kinds of data will be there, and we have a different kind of application that you can do it on that. So we can have a simple aggregation statistics techniques we can use, or you can use kind of a data warehousing and overlap things where you can, if you given a large data, you can slice the data or dice the data, roll up the data. So all these operations, overlap operation will be done. Overlap is online analytical processing operations because the data is organized in the non-normalized form. Then we can use for the indexing, searching, and querying because today we want to retrieve very quickly. Right? Then you have indexing. Suppose in a Google browser, suppose Google Internet, suppose you type some of the keywords and you are waiting for the response, right? And if the response takes too much time, then we may feel that okay, we may shift from one browser to another browser, right? So when the data is increasing, like anything, every day data increasing, but still we're expecting very fast responses, right? That means there should be a lot of technologies are needed for a given keywords, searching the entire web and retrieving the information. That is actually more interest to you, more relevant to you. So a lot of things we require very good number of technologies required for indexing, searching, and querying also. Now for this we have already seen this knowledge discovery techniques like data mining and statistical model. So this is a taxonomy will be useful for us when we are defining it, because suppose this is one of the research scholar working in the sequence mining. He brought this data, he brought taxonomy for his problem statement. So because he's working in sequence mining, he was trying to classify the data is in the sequential data or non-sequential data. If it is sequential, it could be like a temporal or non-temporal. Then we have to go for a time as having any role or not. Right? If a temporal data, it could be like a continuous data or discrete data. And suppose these are the examples. These leaves are examples actually given. Suppose if you are working a stock market prediction, that means the data will be mostly on the continuous. Then you have to do which kind of a technology that you can use for the purpose. But if you are using speech, then maybe it should be these things you can make. So you can decide which are the technology that you can use to support that kind of a data. So then once we understand the data, now we need to go for a bit different how I can process do the data, or maybe some kind of a pre-processing things, because the data is arriving, and then we are applying a algorithm and then getting some kind of inference out of it. But when you are applying this algorithm, we need some kind of a data pre-processing stage. Right? So in where we do the aggregation, sampling, and this dimensional reduction and feature subselection, where if we have a large number of features, a large number of attributes or collected the information, but because this is like, suppose if it's like in attributes have like a few hundreds, it's very difficult for the algorithms to learn from that. So can we reduce this n attributes into like a p attributes? Can we reduce? Where's n less than p? So this is called a dimension. That means you have n dimensions or n features, n attributes. So can you have from n? Can I choose only p out of the n? One can do straight away. That's okay. See that which are impactful and non-impactful, which are significant, not significant with respect to the given problem, and then you remove those attributes. Okay. Our second thing is we do not know exactly which one is impacting or not, but you can transform this data into the a lower dimension. Suppose if you have a two-dimensional data, right? This is two-dimensional data was there. Now I want to make into the project into a single dimension. Then what will happen? Everything will become fall on this one, right? This will fall. It's not that only you have a x1, y1. The data point is x1, y1, and here it will become z1. The z1 is not exactly neglecting y1 or maybe neglecting x1. No, it is transforming these two, transforming to the z1. So a lot of good. If you are looking only some of the features, only feature subset reduction. If you're reducing the dimension, there can be. So here, reducing the dimensions, so there may be information may be lost, but the information you can see, it should be as minimal loss that is possible. The next is like a feature creation, because identifying the features also one of the important aspect. Or even sometimes we need to create new features to do the analysis. Then another technique is called discretization binarization. Here, suppose if your algorithms are mostly focused on the discrete data, then if you have a numerical data, then you need to convert the numerical data into discrete data. So usually that we call it binarization. So that means you are making into suppose into buckets. Right? Suppose you have a age 0 to 100, can any values between 0 to 100 will be there. Then you can see some of them are like a young, some of them are middle age, and then maybe old age. Right? So you can transform into this one. And if needed, you can also go for the attribute transformations, because sometimes you can see the 2 or 3 attributes contribute to the more, so I can add that and then maybe transform to a new one. Mostly when you have this calculations, we have these attribute transformations. And look at some of the tools and techniques that are available today. And mostly they are the Apache Spark. They are developing, adding a lot of technologies towards to this to do these data science applications. So it's mostly a distributed data analytics engine. So that's what they claim. And then here, as I mentioned earlier, this RDD, resilient distributed databases, is one of the most important aspect of the core of this Spark. They develop the stream processing. They have so many things. The libraries are having like a stream processing. You have a Spark SQL to retrieve the data. You can apply machine learning techniques using the mlib things. And you can also address the graph related problems by modeling the data into the graphs. Things are available. And the advantage is this Spark. You can also write programming in either any other programming language you know, either Python, Scala, Java, like this. Okay. Now today, this packages like R and Python, they also have a lot of libraries that can be worked with this data science. And it is good that we should know that many of the vendors, like today, the Google brought a Google Cloud Vision API. Yeah, some of you can Google Cloud Vision API. So if you just type a Google Cloud Vision 1, you will get a very good tool. There, you just drag and drop your one of the picture that you drag and drop. Then immediately it will give the objects which are there in this one, maybe like a table, maybe a person, kind of things. Any text is there, it will do the text also. And it also says how much each one is contributing. And also provides a JSON so that if you want to use in your application, you can directly use that JSON information. And you go to the Microsoft and then type say Microsoft Cognitive Technologies, or maybe you can type like a sentiment analysis. So you will get a screen there. You type any kind of things, and then you just press the button. Then you can get this whether it is like how much is a positive or a neutral you are having, a positive sentiment or a negative sentiment or neutral. It will give you the information. Just you can go and type it. That means all these big vendors, Google, Microsoft, Amazon, Facebook, all these big vendors, they're now starting about developing the good data science applications, data science tools. Because all these are available today. Okay. Now there is of course this is the old one given by the SPS, but still it is a good modeling aspect of it, how to approach to solve when we have some kind of problem solving. Okay. So it starts from the business understanding, because somebody has to, suppose if you are trying to solve a problem, you should have a good understanding of the business also, the domain aspects of it. Or you can take a domain knowledge person who is having. So this business understanding, then you have to have a data understanding, because you given the data, you can do the data understanding. So here you can use a lot of statistical mathematical techniques you can use to understand the data. So one of the things is EDA, the exploratory data analysis. Right? It will give a very good even people will try to find out whether a particular attribute is actually having any relationship with the other attribute or not. Or you can start with a null hypothesis and then try to prove that one, okay, it's null hypothesis not good, then you can go for alternative hypothesis and then say, yes, these two are related based on this kind of a p-value, right? You can find. So a lot of analysis can be done with the using EDA. And also you can understand whether data is a categorical data or nominal data kind of things. And you can use simple scatter plots or visualization plots you can use to get these histograms or box plots you can draw and understand this data. Then once you understand the data, you can prepare the data for modeling purpose. And in the data preparation, there are more number of steps will be taken, because this is the data that is actually going to the modeling perspective, modeling activity, than the data that you are already given to. This is raw data, right? Here you are getting the raw data. You need to pre-process it or maybe data prepare it. Suppose sometimes you will have some value was not captured or maybe not entered properly. So this is called missing values, right? So how you can impute the missing values? Because if your model expects all the values, suppose you are having these 4 values, model is expecting all 4 values, but when a particular record you miss this value, then how the model will behave was not known, right? So then it is better that you estimate this value or generate some value of this one. There are several imputation techniques available. Suppose what will happen in particular all the records, you can see the brute force technique is either you can take average value or maximum value, minimum value, or most frequently occurred value. So these are different approaches that you can follow. If you want to be more advanced things, then you can look at it whether what are the other attributes. This attribute is like a C, it's a B, C, D. Assume that A, B, C, D is attributes, and this C is also have a related with the B, because you already know B and C are related attributes. Then you take only those attributes, the information, because here in the B you already have for the suppose the value for available here for B and C here. So if this suppose for B it is same, then you can look at from this. That means we can use some kind of a neighborhood approach and you can estimate the values. So all these are very important techniques while doing this when going for the data science. Of course, bending and discrimination, we discussed it. Okay? And then identify the features, which are the variables, that important variables. So all the things will be there. A lot of feature engineering techniques can be used there. And do some kind of a preliminary statistical analysis before going to the advanced techniques. Right? Then you can do some simple correlation analysis, regression analysis. You can carry out, see that on which are the features are actually correlated. Like you can see here, I mentioned the correlations and all of this can be carried. Then you can build a model on the given data. So this model building is based on the algorithm that you are choosing. Right? You can use any kind of a machine learning algorithms, and you can see how the time series, random sampling, all this can be done. Okay, apply some modeling techniques. So here actually today a lot of tools are available to develop different models. But the data scientist role is which is more appropriate. Okay. Then once you build the model, you get the results, and that needs to be evaluated. The model need to be evaluated. A good number of techniques are again available for evaluating the model. Suppose you can have like cross validations, right? Some kind of a comparative analysis. And sometimes you can say that the models will be over fitted or under fitted, or maybe some kind of parameter tuning. And also look at the kind of a visualization. Again, you can carry out some kind of good visualization things, how it is happening. And then if your evaluation is not able to properly, you are not satisfied, then you can check with your business understanding, and then again it will go in the cycle. So this is called a crisp data mining methodology. So cross industry standard process for data mining. So if we can understand this cycle, that means the data science process will be completely clear for us. So now this, if you look at this data science landscape, so it is go for the descriptive and predictive. Now we are mostly focusing on the perspective things. So like this here in the descriptive techniques, they given a set of data, we try to infer this data. What does it mean? Right? Suppose if I understand that one, okay, this is the grades of the students are like this. So what I can infer, because you can say most of the students are going below average because of like this. I can infer one of these things. Right? The prediction things we are trying to predict the future. What is the kind of a prediction that we'll get? Like a weather forecasting, sales forecasting, all things like prediction, right? You are getting what will happen in the future. But now the new thing is coming as like a perspective thing. This is an example, like suppose I'm not feeling well, I'll go to a doctor. Okay, the doctor look at some of the parameters, like my temperature and all the things. See the various parameters. He'll test the various parameters and diagnose that when I'm having a fever. Okay, so this fever is a prediction because these are the symptoms. So symptoms, I was showing the symptoms, and these maybe tests are there, and then he's predicting it. So his prediction is okay, 100% true. Suppose he's predicted very nicely. This doctor predicted fever. Okay, but suppose you can say if the prediction is good, it's over. If the doctor says yes, you have a fever, you can go away. Maybe you should be able to prescribe also, right? Prescribe some medicines to cure that. If you don't do this, this entire process is. Similarly, you can see here, you can do the good predictions, but you can see how my business can be run. Right? This is what you have to prescribe. Otherwise, how you can know, you can proceed. Right? There's the strategies or whatever to be done, you can make it. That means I'm not only looking for insights. What I'm looking for is mostly actionable insights. That means which are the actions that I can take over. Suppose if you can say something that one, okay, you can get a productivity by 30% if you can recruit 100 employees in the next quarter. Right? Maybe that may be your prediction. You can give this kind of a thing. But is it possible to 100 people you can recruit of the similar skill set? If that is not the case, there's no point in recommending that strategy. So that means you can have a lot of insights can be there. You have to come out only that actionable insights which are possible to improve the business so that the business can be having a added value. So now comes to this actual process. What we do, these are the steps are there. You can get the data, right? Because when you access the data can come in any format like Excel, HTML table. Because today even the HTML pages also will be data. Your presentations could be a data, right? Or your weblogs could be data, or we were accessing mechanisms to the data, right? So all the things you can see how you can get you're getting the data. Then you can pre-process it, use some kind of clean data, and then transform the data which is useful for your modeling purpose. Then finally you build the model and visualize the things and then communicate to the end user. So the building model could be, you can use a descriptive models, predictive models, prescriptive models, or a combination of these three also, because we cannot say any one only will be useful. You can use a visualization of the data using either EDA tools or maybe some kind of a visualization tools you can use to do that. So transforming the data could be like a filtering, summarizing, applying common everything, missing value generation, everything you can have. Of course, missing value will go in the cleaning the data, but you are transforming the data which is suitable to the applying this algorithm. So here we have a, with respect to data science, the new terminology is also coming into picture. Some of you are very good to learn this data science. They will also tell the word called data wrangling, because the new terminology is coming in this one, data wrangling. Okay. So these three steps together called a data wrangling. Some other things are also coming like a data provenance, data curing, data curation, right? So these are the people are coining these new terms while working with this data science. So all these are mostly part of this one. Data provenance means you are trying to find the origin of the data. Because now if a data was generated here, some data, and the data is transformed, and then not this transformation, the data has gone to another place, and then it moved to another place, moved to another place, moved to another place. Similarly, suppose you send a Twitter data and that is forward to here, and he modified the content and sent to here, and he may be changed and written some kind of response to this one, and there may be another response come here. Now you want to say from where this particular data element was generated, who is actually generated this one, right? So you have to make this one. So you need to know the origin of the data. So these three belongs to the steps of the data wrangling process. So now coming to this last step of data science, which we want to apply some learning approaches. The commonly learning approaches we usually do is maybe learning by examples, because we see some of the examples we show and then we do it. Suppose if you ask some kid to do something, like suppose you open the door in some form, then when a kid comes, he will also observe you and then also open the door in a similar way, right? Suppose if you have some kind of a dust was there's a junk is there on the floor, and you pick up and then throw it out, then he also feels something was on the one, he will also observe that and throw it out, right? So many of the times the learning approaches was done by the examples. You can see, you can give this, these are the examples are there, and then from these examples you can say a new one is there, can you predict what is this? Sometimes we also learn from the mistakes, right? We do some kind of a mistake, and then we try to say how to address that mistake, overcome that mistake, then you can learn more. So people are looking like a reinforcement learning. Some of you familiar, we talk about reinforcement learning. So that means you try to get it, and then see based on this one, you try to look at this feedback. What is this one, and either you give some kind of a award, or you can give a penalty. So if it correctly, you can say it is giving a award, that means positive cost, or if you give a penalty, so negative cost. That means you are learning, you are changing this one, right? in the environment you are changing. So by learning mistakes, one can learn it, and of course, learning by evidence. So that means it's a lot of evidence reasoning can be carried out, and then see how we can learn from that. Of course, there are so many learning things are there in the from the AI onwards. People are coming with the different learning paradigms. So now IBM actually a few years back they actually developed a game called Jeopardy, right? So this IBM Watson, they want to compete with the computer, right? So of course this is actually developed learning by mistakes. So what they developed some good machine learning algorithms that allows the computer to become smarter as it tries to answer questions and to learn as it gets them right or wrong. Because the system is there, and then they will ask questions and they'll say based on right or wrong, it will try to answer. Similarly, you may be seeing this chess game in the chess game, right, in the computer, which actually cross-power lost the game, lost his game towards the computer. So that means all these things they are learning. But this IBM, which was started, is based on the learning by mistakes. So there are so many data science or data mining tasks are there for learning from learning perspective. So there's called a classification, clustering, and regression, associative mining, deviation detection, summarization. So these are 6 broad techniques. Of course, you can have so many, but these are 6 are broadly things are there. Where in the classification, given a set of data, we want to group the data based on some kind of a parameters. Maybe I can say this is the one group and this could be the another group. So you are finding this separating the data with the 2 groups. Suppose if you have a group is like one is 0 group and another 1 group, or maybe this is like a high and this is low, something like. So, but in the clustering also does the same thing. This grouping of the data. Clustering is also grouping of the data. But the difference is here you have some kind of a supervisor who can say how you can do this division. So this is called a supervisory classification. That means you have a data set, and you have one of the attribute as a class label, and this class label will give you information about the number of the kind of a class that it belongs to. So suppose if you usually call this like training data, so what it does is if you have this kind of a data, so this is the kind of a class you are having. Suppose you can say the 2 class problem, you have a high and low, or maybe you can say positive sentiment, negative sentiment. Suppose assume that positive sentiment, negative sentiment. So the kind of a sentences that belongs to positive, the sentences kind of that belongs to negative, right? So that means you want to make it separate based on, suppose based on this data, this is the supervisor, right? Based on this data, this driving this separation. But whereas in clustering, we don't have any such kind of a label things. There's no class labels. That means there's no supervisor here. This is like unsupervised classification technique. It's an unsupervised classification technique. So here it's like a more coming. There's no supervisor who can say, okay, this row, this belongs to here, this belongs to here, like this, making rules. But here, based on the nature of the data, it will try to discover. And the nature of the data will also be helpful in describing the data. So that's why it's called a natural grouping. This is called natural grouping, whereas this is called a classification. Means we use some kind of a class label will drive this grouping. This regression techniques, most of you may be familiar in the regression techniques. Like you can have a simple regression like a linear regression, or it could be a non-linear regression techniques can be used. But this is also like mostly comes under supervised classification. But the difference is here the response variable or even the predictors also are numerical. Here they are categorical. Here what is the response variable? Response variable is the class label. Class label is always the discrete or categorical. So here it is like in numerical values. That is the major difference here. This response variable is always the numerical here, but here is the categorical. Associational mining is actually more concerned to with the data mining aspects, where you can see an item A going along with the item B. So actually they started this problem with respect to supermarket, and say if you buy an item, suppose you're going to buy maybe a TV, right? And then you may likely to buy uh, you may be likely to buy maybe a good speakers, right? So if you have such kind of a patterns are there, it is useful to do the cross-selling and upselling kind of a things. So another set of techniques are they're called deviation and change detection. Mostly from the, if you look at this like anomaly detection in the networks, suppose if you want to find the anomaly detection things, anomaly intrusions, or maybe fraud detections. So all these places we are maybe your spend analysis. So there you usually go for, usually your normal pattern is be like this. So your spending behavior like this, suddenly your spend is increased in a particular day. What can you identify that? Maybe your credit cards are spending is be there, and then maybe there may be some kind of a spending could lead, maybe leads to a fraud, right? So one of the techniques that are useful for here to develop this. And summarization is also another technique where people are using a simple statistic, simple maybe you take the total, because if you have a large data of a report, better to show in terms of simple graphs, maybe some totals and everything. Or it could be like a more compressed form of a representation of that one, the data in summarized form. A good example could be if you have a news article and it could be summarized. This news title could be a news caption, could be a good summarized form of this one. And you can find the importance of the summarized one. See, if unless your title, this is not your news item, if this is not interesting to you, you may not go and read this one, right? So that means you should be more effective way of representing in a more summarized form, because you can see this is a more text which is having a few hundreds of the lines, but here your caption could be like a few words only, right? If you look at this one news article, it is a few words, and that will be giving a more depth understanding about what this content could be. Right? So that's this is a good one of the good technique for the summarization. Even Google also, suppose if you give a browser, you're giving some keywords, and if you observe, there are these links are coming like this, right? On the first, suppose you take any first page. If you observe carefully, this is giving like a 2 or 3 lines will be given here. And those 2 or 3 lines are not exactly the replica taken from one particular document, but they are portions of the document from where it was generated, these 2 lines. Of course, they are not changing the word as it is, because they are highlighting also based on matching of the words. But they're taking, these are the relevant segments of the data, and that they are showing in this one. And suppose when you get this one, unless you can see, if you're not satisfied with these 2 lines, you never click on that hyperlink and go into the actual page and look at it. That means you should require a good summarization technique to do that one. So that's why the classifying learning problems will be mostly in the supervised learning, right? Because you have some kind of a label data is the given and you are training it. The unsupervised learning, where there is no labels are not given, but from based on the data itself, the nature of the data, that means data attribute values itself, it will try to do it. And the reinforcement learning, where it try to learn from the experience, look at the environment and get this information out of it. And you can take a sequence of the decisions, okay, and you can able to either reward or penalize for the action that you do it. And the idea is you have to maximize the cumulative award at the end. And there's one more thing is like self-organization, where the system will be configure itself, because today this is what we are looking for. Suppose if you are having a driverless car and the car is going, and then suppose there is some kind of the other two cars are going on, suddenly one car is slowed down, then you have to automatically you have to take your plans, right? Self-immunable systems, because somebody your is you have a system which is very confidential thing, but suppose somebody able to reach to this one, it should be able to destroy itself. Or maybe it should be recovered. Suppose if it's like a diagnosis required, it should be recoverable itself, self-repairable, self-configurable. So those kind of systems are coming, because a lot of works is happening in the oil pipelines between the countries. One cannot go and see what is happening in the pipeline at some damage in the pipeline, right? Because the pipelines may be under the sea, but it should be able to identify where the damage was there and could be able to self-configurable there itself. Even so many space aircrafts you may be seen, they're having this kind of a self-organization kind of things. Now the deep learning models are coming, which are part of the representational learning, where instead of taking these features, they are already they are actually able to take care of that features also learn automatically, because you don't require to explicitly specify that. And that's why deep learning actually started with the from the domain of deep neural networks, where you have more than one hidden layer for the deep neural networks. If you have more and more, then they call it deep learning. But today, this deep learning also changed to the more number of aspects. And of course, deep learning can be a supervised, a semi-supervised, or could be unsupervised also. So these are the, like a few examples just I mentioned, how you can classify a tissue. Suppose if you have a gene expression profile data, so can you identify the tissue which are the cancer classes? Or maybe suppose if you have a digits are there, can you classify, recognize this is the characters, because each one character, each one can write. So a handwritten digits is still a good research area still going on, because it's very difficult to get a more accurate results. Because and also if you go to the cursive writing, it's very difficult, right? Suppose the way people will write this cursive writing, is very difficult to analyze that cursive. Suppose if you give somebody is given an image data with some spectral bands information, so, right? Then you can say how the usage is going, the land usage is being. So this is land usage and this is predicted land usage. This is supposed to be. So how much accurate prediction versus this one, right? Maybe based on the pixel values, you are classifying a particular pixel is a like a red soil, or it belongs to a cotton, it could be vegetarian, or it could be rocky area, it could be water bodies, right? Anything that you can classify based on the pixel value. This is feature engineering. Actually, you can have a forward selection process and then a backward elimination process. There are few things, because somebody has given a lot of features out there, how you can try to reduce this to the P, from N to P, right? So you can go, if you are only choosing few of them and few of them you are neglecting it, suppose you are neglecting few of them, then you can see which are the algorithms are, which are the things that you're going. Suppose you go for a first time, you go to the consider all the attributes, and consider next you can say -1 and check it every time. If you are improving the accuracy, then you can go ahead and do it. So you can do either forward biases or in a backward. So also the models also classified in terms of a mostly like parametric models and non-parametric models. Like linear regression is a linear model, is one of the parametric model where you can estimate the parameters, right? Because we want to, if you have this relationship, this one, we are trying to, these are the parameters, right? If you say why this is usually intercept and these are the slopes, right? So you can estimate this beta 1, beta 2, beta p. So these are like a parameter estimation. So now what will happen if you're given a model? The thing is, the learning the model is nothing but the estimating the parameters. So that means the problem is now boiled down to estimating the parameters here. So that's why it's estimating function, because we want to, this model is nothing but a function, right? We want to establish, we want to predict this function or establish this function. We will choose a function otherwise. So then there is a possibility that one, okay, you can have it could be like a simple linear fit, or it could be like a quadratic fit based on the data. And also, see, one is like this function. This function can, suppose if the function is not giving good values, you can able to modify to another function. That means another model you can choose to reduce the error rate or improve the accuracy. So those errors are usually called like reducible errors. But whereas some of the errors are coming, because that's why usually we'll say y is equal to beta 0 plus beta 1x plus epsilon, some error, right? This error is like a irreducible error. Maybe this error may be reduced to the measurement error itself, or maybe not captured, or maybe some kind of system problem. So which cannot be reducible. That's why they call it irreducible error. And you can look at this, how the relationships are happening in the plots. You can look at these red dots are actual points, and you are fitting with a plane, fitting with a curve, right? So that means there are two attributes: eras of education, seniority, and with respect to income is your response variable. So with respect to this one, era of education, how your income is there. With respect to seniority, how your income is goes. So the income is a function of education, seniority. Now you are fitting this one. So the difference between the red dot to the actually on the plain dot and the curved dot is the error rate, error you are having, right? And you can have another fit. You can see, suppose if you go for a linear fit, you can have a plane rather than a surface. We are having a surface, a curve. You are having a plane. So then there will be this, but parametric models what you have sometimes will be overfit. Overfit means suppose if your land model, of course here may not be here in the land model. Suppose if all these red dots, if this surface will fall under this red dots, that means every each and every data point is correctly estimated. Is correctly based on the point, the function, right? So then we list a overfit. That means any unknown sample was given, it may not be, you do not know whether it will fit or not. But for the given data element, that will be fits. So then this non-parametric methods, they are actually, in non-parametric methods, they don't have any assumption on this functional form of f. So whatever the function that you are taking, you are based on the function you are making, you are going into. Right? So of course, each one is having its own pros and cons of a parametric and non-parametric approaches. So maybe I will stop here. So here you can see if this is like a wall. All the red points are exactly based on this plane, the surface, right? It's like overfitted because you model very appropriate, you model very correctly. That the accuracy here you can see the training accuracy could be very 100% because every point was on the surface only. But when an unknown sample was given, where we are not sure whether it comes good or not. So that's why this is called a overfitting. If every point is on this one, this is usually overfitting. Some of the examples. So I just thought of some algorithms I can take, but anyhow, there's the classification models like a nearest neighbor approach. Usually, based on the neighbors, one can able to choose what I am belongs to, who are my neighbors. Because sometimes we'll go for our friends, right? So that's why you want, based on the neighbors, you can choose which you can predict this point. So this point could be like a k equal to 1. So based on the one neighbor, if you are deciding this is a new sample, you want to predict based on the one neighbor. This could be like negative. When you take it two, one is positive and another negative, correct? The two neighbors if you want to take, you do not know whether it is a positive or negative. It's a tie. Here it is tie is happening. But in the case of k equal to 3, you can see 1 negative and 2 positive. That means it could be like a majority voting is a positive. Here is a negative, correct? So when as k is also moving increasing, you can have this it could be positive and it could be a negative kind of thing, and there could be anything. So because to find the who is close, you can use different distance functions, distance metrics like Euclidean, cosine similarity, Joker similarity kind of things. Okay, so just I'm skipping these things every time. And there's a clustering like unsupervised classification. You have a good algorithm, is a clustering algorithm, where initially we can say randomly partition the data, given data, and try to find the mean of each one. Okay, this is the mean of each one, right? Fine. Then find the distance between each object to the two means, and assign to the closest one. Then you can see here the points are there. This point is earlier first in the random partition, it belongs to this one, but it is closer to this. So now this was moved to here. This point actually here, this is the point. Correct? This is the point actually belongs to this one in the previous case. Now it moved here. Correct? So now again you group this one and try to find the new mean and repeat this process till the mean there is no change in the mean. Now, of course, the whole philosophy of all the techniques is, so we need to understand the ideas behind the techniques, because how the techniques was developed, and then because we want to apply them, correct? So how to use them. So one has to start with the simpler methods first, and then go ahead for the sophisticated ones later. And then third is you have to accurately assess the performance of a method, because you have to see whether this is working very good for you or very bad. And sometimes what will happen, the simpler methods also perform well, better than this new generation things. And today people are working in the conversational AI, where to analyze the conversations, right? To analyze the conversations, people are looking at still the old logical formalisms are better than today these deep learning methods. Because at least in the logical formalisms, you are writing it like these are the logical formalisms, you are very sure that one with that words that is good. But in deep learning models, because they are black box, you do not know how they are becoming. Of course, you require a statistical learning things, because if you want to be a data scientist, not in addition to you are having a deep learning and then those techniques, you should also have a good statistical learning. So most of the times we say that we have a good common sense, that human beings have good common sense. But my thing is like it may not be so common, so we can unbox it. So, and I can take some questions here if you have. Yeah, any questions?
Participants, if you have any query, you can go ahead and ask. Sir is waiting.
Yeah, there is a chat message.
Yes, sir. I am putting it in the chat. How can we implement deep learning in data science?
Yeah, they say so how we can implement deep learning in data science. See that this is in the data science, one of the aspect is modeling, right? So there we are using these deep learning models, because entire life cycle data science start from understanding the data, right? And then visualize the data, the modeling the data, and again you can say evaluation of the data. So where the modeling parts are of the, you can use either machine learning algorithms or you can use deep learning algorithms. So any of these algorithms that you can use it. So that's why today, if you can look at the given a problem statement, we are going for applying this deep learning techniques. Maybe you can use, suppose if you want to classify a face, you want to recognize the faces, right? You can use a C and convolution neural networks. So all this part of the data science. Data science is a bigger umbrella of this.
Sir, currently we see that data science, it has been implemented for means in the sector like finance, cyber security, those things. In context to manufacturing or production engineering, means how it has been implemented so far as the present scenario is concerned. Means data analytic, what is the scope for them in manufacturing or production engineering sectors?
Actually, it's very see the data science is nowadays in almost all areas. Okay, so you can see this is some of the manufacturing data. Now you can see. Suppose this is not automobile data. Suppose usually the people will give the complaints, customer will give complaints, and technician comments, action taken. So this is the kind of a data we are having, correct? Now thing is, it's good that one can see how we can populate it, and then good at tagging it, and then see that you can develop a early warning analysis. Suppose you can see how the complaints are coming from which division kind of things. Now people can look at it. Suppose there may be so many complaints are coming from the engine, right? Or maybe some the AC. So you know from what to be done, everything. So like that, there is a good number of techniques are there in manufacturing also. And today, today there's a if you know in the manufacturing plants, big plants, preventive maintenance is a common, right? Very common. Now people are going for the predictive maintenance. So that is like a very things that one, suppose you can say health of each component, estimating the health of each component. It may not be exactly the parameter specifications given by the manufacturing provider, but you can see the usability of this one. Today, suppose if I am driving a car, if I drive a car is different from how my son drives a car. Right? Maybe I may be using the brakes not much as compared to the. So do you think that in both the cases the car will come in the same kind of lifetime? Maybe different, right? But from the manufacturer point of view, it may be same. So that means it's not the life value of this one, but it could be like a predictive. It's not a preventive. It could be like a predictive maintenance can be. Yeah. So that's why a lot of data science approaches are following in the manufacturing also. So there's few more questions are there. How can we determine the number of hidden layers? Actually, this is a big question, as there's no clear answer for that one, because people are still trying it out how many kind of hidden layers they can use it. Okay, so that's why now they are leaving to the algorithm itself. So it's very difficult because if you increase more number of hidden layers, the complexity will increase definitely. But then only based on the experience, one can able to decide how many hidden layers could be the useful. One should be good in mathematics in order to learn data science. Need not to be exactly, but one thing is that one yes, the 10+2 maths is sufficient. The intermediate level, whatever that mathematics that we learn, that itself is good enough for doing for data science. We are not looking for a MSc or my masters in stats, masters in maths like that. No. Not that much not required, but basic matrix operations, but the simple aspects that you can like a linear regression kind of things. So simple things, or maybe simple probability techniques also good. Of course, if you want to learn high-end algorithms like hidden Markov models and everything, if you have a good knowledge about mathematics, it's really helpful. How we can use deep learning in cryptography? Give some examples. Yeah, actually, of course, cryptography is mostly on the mathematical models that are even in the elliptical cryptography or maybe the quantum cryptography which are coming up, right? But thing is, the estimation of the key length, or suppose if you do the encryption, suppose you using cryptography, you encrypted the data, but now I want to analyze the data without decryption, right? Or in another case, suppose not exactly cryptography, you using suppose privacy techniques. So how you can preserve the privacy? At the same time, you can extract the knowledge out of it. So those are the aspects which are working in this deep learning can be useful there. Mathematics excellence needed in data science, not exactly, but if you have mathematics, good mathematics, then you can learn more quickly. But non-mathematicians also can use the data science things. Feedback link, please. Are there any criteria that can decide whether data science can be used to solve a particular problem, or can it be applied to all? So actually, that's why in my first initial slide itself shows we need to understand the problem clearly. Suppose the problem can be addressed with a simple Excel sheet. Why should I go for any other things? If I call exploring the Excel sheet itself is a data science, yes, okay. But because nowadays we are defining our own definitions. What mean by data science? What mean by deep learning and everything? Like in olden days, suppose if you look at like Newton's laws, you take 100 textbooks of physics, Newton's laws will not change. The definition will not change. But today's scenario is not like that, because these advancements in the technologies, you can define what does it mean. Suppose if I do the simple aggregation, simple visual techniques, simple scatter plots using Excel also, Will you call it as a data science? Or if you're using only deep learning techniques only, then you can call it data science. It's the individual to take a decision call on that. But in the both the cases, if it solves to the business and if you added value to the business, definitely you can call it as a data science problem. So what are the facts we can do research using deep learning data science? As I mentioned, so almost today's you have a chatbots or RPA. All these are good examples of today real world words. Not only that, suppose somebody has understanding natural language understanding, correct? Suppose if you ask a question, that means you want to retrieve the information, correct? Suppose somebody is giving a speech, can you tell the speech could be like a whether what are his emotions? Or can you predict an emotion of a user whether he will go and he is in the distress or not? Or you want to find in the WhatsApp, can you find a message in your room or not? So all these are good problems which can be solved using deep learning things. Okay, then thanks a lot for your patient listening this one. And thanks to the Professor Trupti Ranjan Mahapatra, who actually called me and informed me about this one. Thanks a lot. Thanks to all of you.
Hello.
Yes, over to.
Yes, sir. Thank you. Thank you very much, sir, for accepting our invitation within a very short span of time. I thank you for this sharing with us your valuable experience and expertise in the domain of data science, and I am sure that the participants will also be agree with me that this particular session is full of knowledge and basics of data science, and this will be very much useful to them. So thank you once again, sir, on behalf of our department, our coordinators, and the participants. I thank you, sir. Thank you very much.
Yeah. Thanks to all of you.
Participants will be starting the next session at 3 p.m. The expert speaker is Dr. Lalit Singh. He is a scientist in the Department of Atomic Energy. So please join 15 minutes prior to that in order to avoid any technical issues. So see you at 2:45 p.m. Thank you.